Hey everyone, so in this video we're going to look at some more examples of applications of functions. So number 6, if the total cost of producing x units is given by c of x equals 1200 plus 15x plus 0.4x squared, then part A, write a function a of x that represents the cost per unit when x units are made. Alright, so essentially what we're going to be doing here is going to be finding the average cost, because it's the cost per unit, which is just the average. Alright, so how do you normally find an average? To normally find an average, you take the total and divide it by the number of items that you totaled up. All right, so for example, if we were to take, say, the numbers 8 and 12, to get an average, we divide them by the number of things that we added up, so in this case 2, and we would get 10. So same thing here. To find an average, it's going to be the total cost, which is given by the function c of x, and we divide by the number of units, which is the x. All right, so let's go ahead and do that. So we have a of x equals c of x, which is the 1200 plus 15x plus 0.4x squared, and we divide that by x. All right, we can go ahead and divide each one of these by x. So we have 1200 divided by x. We can't actually reduce that. For 15x divided by x, that would just be 15 because the x's would cancel out. And then for the last one, we would have 0.4x because x squared divided by x just leaves us with x. All right, so that is our average cost function, or the cost per unit. All right, so for part B, what is the average cost per unit when 80 units are produced? Well, for that, all we gotta do is plug in 80. So it's gonna be 1200 divided by 80 plus 15 plus 0.4 times 80. Put that into your calculator and you should get 62. So $62 the average cost per unit. All right, number 7. If the total cost of producing x units is given by c of x equals negative 0.08x cubed minus 6x squared plus 480x, then for part A, we're going to write that average function again, the average cost when x units are produced. So again, a of x is equal to c of x divided by x, which in our case is negative 0.08x cubed minus 6x squared plus 480x, all divided by x. If we divide each of these by x, we get negative 0.08x squared minus 6x plus 480. That's our average cost function. What is the average cost for producing 30 units? We just go ahead and plug in 30. So negative 0.08 times 30 squared minus 6 times 30 plus 480. Plug that into your calculator and you should get $228. That is going to be the average cost. All right, number 8. A neighborhood lemonade stand has a revenue function of r of x equals 0.55x and a cost of c of x equals 10 plus 0.05x. Find the break-even point. So what does it mean to break even? It means your costs are equal to your revenue. Because to break even means you didn't gain any money, you didn't lose any money, you just broke even. So in our case, what that really means is it's when r of x equals c of x. That's our break-even point. All right, so we want to know when r of x equals c of x. In our case, r of x is 0.55x, and c of x is 10 plus 0.05x. So all we have to do is solve this for x now. This is just a linear equation, so we just subtract 0.05x from both sides. So we get 0.5x equals 10. Divide both sides by 0.5. And we're going to get x equals 20. So the break-even point is when we have 20 items. So any less than 20 items, and we're going to end up just owing money. Any more than 20 items, we'll actually start to make some money. All right, number 9. Company sells a product with a cost function of c of x equals 4x plus 96 and a revenue function of r of x equals negative 4x squared plus 48x, where x represents the number of items sold. How many items must be sold for the company to break even on the sales of this product? All right, so again, we're talking about breaking even. So we want to know when r of x equals c of x. So in our case, r of x equals negative 4x squared plus 48x. C of x equals 4x plus 96. And now we just need to solve this equation. So since this is quadratic, whenever we're moving stuff over to set it equal to 0, I'm actually going to go ahead and add the 4x squared and subtract the 48x from both sides, just so we can get that x squared term positive, because things like split b are much easier whenever the leading coefficient is positive. All right, so we're going to get 0 equals 4x squared minus 44x plus 96. All right, we actually have a GCF of this before we do split b. So we can actually take out a 4. We're going to get x squared minus 11x plus 24. All right, so now we want to do split b on it. So whenever you do split b, you should end up with x minus 3 and x minus 8. All right, that's after you do split b. All right, so in order to solve this, all we need to do is set both of these equal to 0 now. So we get x equals 3 and x equals 8. So both of these are actually breaking even. All right, so there's 2 spots that we hit break even points. And the reason for that is the first one is we're going from losing money to making profit. All right, so we break even in between. So we're going up. For x equals 8, it's actually the opposite. We were making profit, but after x equals 8, the costs get too expensive, and we're going to start losing money if we make any more than that. So that's when it's going down. All right, you don't really need to know that part as long as you can find the 2 break-even points, but that's why there's 2 of them this time instead of just the 1 of the previous example. All right, last one, number 10. The number of active Facebook users in millions X months after December 2008 can be modeled by the following equation. F of x equals 152.6 e to the 0.0667x. According to this model, how many millions of active Facebook users were there in July 2010? All right, so for this one, X is in months starting December 2008. So we need to know how many months after December 2008 is July 2010. All right, so let's get to the next July first, and then we can just add 12 to that to go up an entire year. So from December to January to February, March, April, May, June, and July. So January would be 1 month after, February would be 2 months after, 3, 4, 5, 6. So July is 7 months after December. All right, that would still be in 2009 though. We want July 2010. So it would be the 7 months plus an entire year, which is 12 months. So we're looking at a 19-month difference. All right, so that's going to be our x. So we go over, we're going to be trying to find f of that 19. So it's 152.6 e to the 0.0667 times x, which we want as 19. All right, now all you have to do is plug that into your calculator. And when you plug it in, you should be getting 541.92 if we round it to 2 decimal places. All right, so what that means is there's 541.92 million users in July 2010. And that is it for applications of functions.